Okay, let's do some rotation transformations with GeoGebra. So first thing we'll do is let's make a polygon that we can rotate, and let's get crazy here. Let's do one that's instead of a triangle, let's go for a quadrilateral. I'm going to go ahead and just trapezoidal. I don't know. Maybe trapezoid-ish. How about that? So anyways, remember trapezoid has to have two parallel sides, and we don't know that those are, so technically we don't know. Anyways, let's go ahead and do some rotation. Now we're going to rotate this polygon, ABCD, this quadrilateral, about a point, and we're going to rotate it about the origin. So here we go. I'm just going to go ahead and put point E at the origin. And then we'll go to our transformations. Again, if you don't see them, maybe you have to click more and then come down here and find transforms. And here they are, transforms, transform. And this time we will go ahead and instead of doing a reflection, we will do rotate about a point, rotate around a point. So I'll click on that. Now that's one reason why I had to actually put point E at the origin, because I knew I was going to need it. Select object to one more time. Select object to rotate and center point, and then enter angle. So here's the object to rotate, and here's the center point. And then it gives us a default of rotating counterclockwise 45 degrees. We're going to do 90. And let's go ahead. Now, before we do, I just want to talk to you a little bit. I want to give you a chance to anticipate. What do you think this thing is going to look like? Where is it going to go? Is it going to go here or here or here? Is it going to, which direction is it going to flow? Is it going to flow this way or this way or this way? I'm hopeful that you're with me on the idea that clockwise, well, hold on, let's do a little visual. All right, so just for the fun of it, I wanted to show you what clockwise meant and counterclockwise. So I pulled up a bunch of, I found a bunch of animated GIFs with clocks. And what I discovered is there's a bunch of knuckleheads out in this world that have no idea what clockwise means, nor do they understand how a clock works. I don't know if I don't remember which ones are which, but I'm just going to try a few of these here. So for instance, maybe it was this one. That one's actually not bad. That one they figured it out. They did it the right way. Let's see if I can. Let's take a look at a couple more. This one I think was okay. It's just that it's going a little too slow for my liking. How about this one? That one you can't tell what the heck's going on. How about here? Maybe it was this one was kind of interesting, I think. Yeah. Okay, so here, just so you guys know, see the shorter hand is going round and round, and the longer hand is kind of standing still. It's exactly the opposite of how a clock works. It's the long hand that goes around, and then the shorter hand kind of follows. So so please ignore that as an example. Oh, and here's another fun one. Here's a clock that's actually going in the wrong direction. They don't go this way, they go the other way. Thank God. Okay, at least it says clock with hands turning backwards. Thank the Lord. Okay, let's find a good one. Okay, so this one's going to be good enough for me. It's not moving quite as fast as I would like, but the deal is this, is that on a clock, this is the second hand, and the second hand is moving in this direction. When you go this way around a clock, we call that clockwise. If you go in the opposite direction, we call that counterclockwise. Of course, in a real clock, the second hand moves, and then the minute hand slowly goes, and then finally the hour hand goes. It starts with this guy, and then this longer guy, and then this shorter guy. All right, anyways, clockwise goes around. If you start at the top, you will go to the right, and that's clockwise. If you start at the top and you go to the left, then that's counterclockwise. Now, the other thing that's kind of interesting is later on when you guys go to learn trigonometry, you usually start over here is 0 degrees, and in trigonometry, if we go, this is weird, but in trigonometry we always move counterclockwise, and we call that we call that a positive number of degrees. So if we go from here to here, that'd be positive 90. And if we go from here to here, we would call that negative 90 degrees because now we're going clockwise. So there is some weirdness in trigonometry about how we deal with positive and negative and clockwise and counterclockwise. Anyways, let's get back to our rotation. Okay, so again, I don't care whether we rotate counterclockwise or clockwise, but we should anticipate. Counterclockwise means that this guy is going to rotate around the origin going in this direction. Okay, so if we go 90 degrees, we're expecting this guy to kind of go this way. And let's see where 90 degrees puts us. Voila! Fun, huh? Not bad, not bad. Okay, so let's go ahead and let's make that a different color because that's what we do. And I'll go ahead and, whatever. And let's go ahead and do another rotation, so transform. And this time, just so you guys can see what it looks like if we rotate 180 degrees. So we'll click on the object, and then we'll click on the point, and then instead of 45, let's go 180 degrees. Again, we'll do counterclockwise. We don't have to, but we're going to. And voila! That's what a 180 degree rotation looks like. Now, one of the reasons where I want you guys to try this yourself in Geogebra is because I don't know that the results are going to be 100% intuitive to you. So the best way to figure it out is try it yourself and see how it works. We'll do one more just for giggles. Let's go ahead and rotate this original object, and we will go ahead and we will we'll go click on the object, click on the point, and oh, never mind. Let's go and choose the transform. Click on the object, click on the point, and this time we'll do 270 degrees. 270. Now, I would like you guys to have some kind of indicator, either in your notes or in the Google Classroom where you leave this for me. I'd like you to have some kind of indication which one of these was which degrees. So we're going to go ahead and add a label. We do that by going here to the Edit Tools and click on the text button, or Show or Hide Label. And I think that'll let us do it. Let's give it a try. Never mind, I was all wrong. Let's go to Media and go to ABC, and that's where we can add some text. And over here, we'll go ahead and put 90. And if we really want to be cool, we can do like 90 degrees. I'm sure there's a way, maybe under Advanced, where you could actually, put the degree symbol, but we'll just do it like that. And then I'm going to go ahead and see if I can copy that. I don't know if I can. Duplicate, yes. So let's try and duplicate. And then we'll put that guy over here if we can. Can we? There we go. And then we will edit that if possible, and that is our 180 degree rotation. Okay. And then we'll duplicate again if I may. Let's try duplicate. And we'll put that this is our 270 degree rotation over here. And I recommend that you try this, but when you draw your original polygon, don't put it down here. Try putting it over here or over here, and maybe try doing clockwise rotations instead of counterclockwise. Get a feel for it. Play around with it. That's one reason why I'm having you try Geogebra, is so that it's really easy for you to experiment around, to explore, and to develop a natural understanding of the material. Now, one of the things that I'm going to ask you not to do is to try to memorize the tables, the tables that you've seen regarding the reflection and the rotation, where in the videos we saw that if you reflect about a line, maybe A comma B turns into A comma negative B or something like that. The last thing I want is for you to memorize that stuff or to read it out of a table. One of the cool things about using Geogebra and exploring is we can see stuff. Like, look what happened when we went from A to A prime when we did the 90 degree counterclockwise rotation. When we rotated this object here, the A at x equals 1, y is negative 2, turned into x is 2, y is 1. So without having to memorize any table, what we can see, and by the way, you could do the very same thing with patty paper, and I think we're going to take a look at that in class. And again, after you do your rotation, you'll see oh, the x and the y change places. We go from basically from an x is 1 and a y is 2 to an x is 2 and a y is 1, and also the y value that changed into the 2, or the y value that changed into the x goes from negative to positive. Okay, so if we so we could say that the x and the y swap places for this a, and the y value changes sign. Okay, so this is one way to develop what the concept is by exploring rather than trying to memorize a table. Okay.